Thank you, Chair, and thank you to the witnesses and Dr. Lockyer. Thank you for telling me about Fermilab. You have a faithful advocate in Congressman Holtgren, and I am now assured that you were put on this panel for more reasons than just separating the Berkeley and Stanford witnesses, who at home would be at odds with each other. Dr. Rowe, I understand that you and your colleagues had to make a number of tough decisions under a difficult set of budget trajectories, and I commend you for rising to this challenge so that members of Congress without particle physics degrees don't have to make these decisions without your guidance. And I am, however, concerned about the consequences of the lowest budget scenario that you were required to consider. And with that in mind, I wanted to talk a little bit about DESI and why that's so important to improving our understanding of dark energy. And if you could also talk a little bit about what the sense of impacts on the U.S. physics community would be if this experiment was not allowed to move forward.
Well, thank you very much for that question, Representative Swalwell. DESI is really a unique experiment in that it can make these very precise measurements of dark energy extending back billions of years in cosmic time, but at a cost that is very modest, considering that its reach can rival expensive space mission capabilities. And the key is to recycle this existing telescope that the NSF has at Kitt Peak in Arizona that they were planning to retire. So we're making use of an existing facility, outfitting it with a modern robotic fiber-fed spectrograph that we can measure 5,000 galaxies at a time with. And there's a lot of excitement around this project, and it would certainly send a very discouraging message to the many young scientists who have already voted with their feet to join this collaboration. They're excited about the science, eager to take on major roles and responsibilities. And also, if we can't proceed with DESI, it would send a negative message to our many collaborators from 10 countries who have indicated that they wish to invest here in this experiment. And they may decide to try to do this experiment themselves in Europe or Asia rather than wait for us to commit if we can't do it.
And Dr. Rowe, speaking of Europe or Asia, if DESI is funded and moves forward as a project, what will it be able to accomplish that cannot be accomplished or will not be accomplished by LSST or by the European dark energy missions and experiments that are expected?
Well, DESI is very complementary to these other missions, as was called out in a community report on dark energy that the Department of Energy asked for 2 years ago. Basically, whereas DESI uses spectroscopic techniques measuring the spectrum of galaxies, LSST uses imaging techniques, taking pictures of galaxies. And by doing these different approaches, they can constrain dark energy with different and complementary methods. Because it's such an unexpected phenomenon, we feel that we need confirmation from multiple techniques to really understand what's going on. So they really fit together in a planned program.
Great. Thank you, Dr. Rowe. And Dr. Drell, as you mentioned in your testimony, this is not your first P5 rodeo, so to speak. You were pivotal in the creation of the first P5. And I was wondering if, thinking broader, you could can you envision this process that the P5 undertook, can it and should it be applied to other areas of research that require long-term prioritization of projects under challenging budget scenarios? And if so, any examples?
So actually other fields use processes that they're not called P5, but they have a similar outcome and are tuned to the specific circumstances of those fields. For
example, how about fields that aren't using it that you think would benefit if they took this process?
I think most of the fields that I can think of, astronomy and astrophysics with its decadal survey, X-ray science with the BSAC subpanels, nuclear physics, they have a very good process. The fields that I'm aware of that really need to do this have their ways of doing it. It's, I think, in some ways hardest in high-energy physics because of the huge opportunity costs of our projects. They are so long that you make a decision now and it really constrains the program many, many years in the future. And it was that additional element of opportunity cost we felt wasn't being taken into account in 2002. But I think actually we, in the P5 process, learned from how other fields do it. And in the way of science, they will learn from how this was done as they go forward in their planning.
Great. Thank you, and I yield back the balance of my time.